Okay, so the mission of this class is to be able to build apps that look like this, right? So specifically, there are a subset of the apps that are out there. These are just RESTful clients. So we're looking at LinkedIn, Pinterest, Instagram, but say, Flickr, Yelp, Tinder, anything that is backed by a RESTful API. So that's how we're going to pull off, this outrageous claim that you're going to be able to build anything by the end of the class, because we're focusing on a very narrow set of paradigms. uh, so for those of you who have done GUI development before, it's in the classic MVC structure. If you don't know what I'm talking about with MVC, don't worry about it for right now. I don't like to kind of stress it too much. All it is if you're building a GUI, there's just very standard ways of like dividing up the responsibility of the app, right, into these different components. And so we'll kind of learn that intuitively as we go along if you don't already know it. Who has made a GUI-based application before, either a web app or mobile app? Okay, so a lot of you at least had that experience. A couple of you don't. That's okay. So this has a very standard structure to your web app in the MVC stack of it, and then the networking client if you're interacting with an API. And it's a little bit different from your classic web program because there's also this piece at the bottom this is the fun stuff, right? We have these phones in our pocket. They have GPS. They have a camera. They have Bluetooth discovery. They can ping devices around them. So there's this other dimension where it's this cool little toolkit of device things. So what I want to do is I want to see if we can kind of derive from kind of first principles / your web experience what it takes to build one of these mobile apps. So for example, if I were to pull up this Twitter application, so this is a Twitter client that we're going to build in the third week. So this is a very simple one, a simple version, and we're going to build a more polished one in week 4. But so the simple version just has, your Twitter feed, and with your normal set of actions, and you can go into a tweet detail page. So I'm going to pause the video for a bit because I want to have a discussion with you on the whiteboard, which is start running through in your mind what are the different things that we'll need to do in order to build this. So I'm going to think about that on the Facebook group.
Cool, thanks.
So for those of you remote, do you guys have like 5 or 10 minutes after class to kind of catch you up on what we did in the first part of class?
Sure.
I'll be okay, so I wanted to rederive these things with you guys because what's interesting is, do you guys feel like you kind of develop one web app, you've developed them all? Do you ever get that sense? No, you don't get that sense. But in my opinion, like if you kind of maybe squint your eyes and you see a lot of similar problems, right? So mobile, one of the interesting things is, if anything, it's even more constrained than the web. I could point to any mobile app. I've never worked very much with the Facebook app, but I could walk into the Facebook app and I could say that I could navigate around it pretty easily, like in any mobile code base, because if I go into a model, I'm expecting to see one of these 4 or 5 tasks, and that's it, right? There's not another task that's in there that I'm expecting to see. I can go to a controller and I would expect to see those few set of tasks, and that's it, So let me kind of summarize this. So on the view side, this is the first thing that we talked about. So I have a lot of good news followed by a little bit of bad news, right? So we'll do good news for a while. So views, well, cool. So views, the cool thing about this is we actually struggled, I think, to come up with more types than we had listed. So I think we listed everything that's on this page on the whiteboard, right? In other words, another way of saying this is that even though there are many, many controls, to build the apps that you have in your mind, you can compose everything using these Lego building blocks. You might be thinking, oh, what about a dialog? Well, a dialog is just div, a view that contains images, text, buttons. So everything is going to be composed of all of these elements. So it's a very small subset. And so let me kind of give you an example. When your designers, and this is the Facebook designers' favorite website for something called mobile patterns. So mobile patterns, what that is when you're building a new app, and this is going to be a task that I'm going to have you do with your group projects as well, which is once you identify your app idea, you're going to choose a very polished, a very nice app that's very, very similar in idea to what you're working on, right? So for example, if you want to build like some kind of delivery application, then it should look very similar to Uber, I imagine, right? So if you look at these things, designers every time they start kind of a project, they'll take a cast at what everybody is doing on their different projects, right? So if you look at this though, these screens look pretty dramatically different from each other, right? But do you see anything here that's not text, images, buttons, switches, fields, maps, web views? So these incredibly diverse screens are all composed, and we can spend hours here, just randomly choosing a topic and kind of assembling these things. And it's even easier than HTML and CSS because HTML and CSS, those layout rules are so complex to me at least, and to you as well if you care about browser compatibility. But the CSS layout rules are very, very complex. With iOS, in some sense, it's much more straightforward. It's weird, but it's also straightforward. It's view hierarchy, which means that views can be contained within other views. So for example, this thing is a div or a view that contains a label. So there's some notion of nesting in the view hierarchy. And then it's absolute positioning. So I mean, like, let that sink into your HTML like brains, because like that's a huge sin in HTML, right? Like HTML does your flow layout for you. It's not the case for iOS. It's not how it works. If I want that label here, I nudge it there, and I nudge this label down below it, and so on, right? So it's this kind of weird world where it's view hierarchy plus absolute positioning with this very small set of controls. So unlike HTML, where I think it would take a while for you to master HTML, CSS layout, iOS layout is kind of a much simpler set of rules. Now, you might be wondering to yourself, well, it is dynamic, isn't it? It's like, yes, but it does it in a different way. We're going to learn about that next week. It uses a system called auto layout you do your kind of manual pixel layout, but then you have to specify certain rules for it where it says, well, what do you want to do if this thing gets a little bit wider because it's an iPhone 6? Should the width stretch or should the margin stretch? And so there's just a different way of specifying your layout rules. But it's built on this foundation of absolute layout plus view hierarchies. For these 6 or 7 controls that we've discussed, first of all, you're going to be using them every day. Secondly, they only have like 3 or 4 properties that you tune per control to configure their appearance and their behavior, right? So this is our very narrow universe. And then there's 2 classes that are very meaty. So there's a bunch of basic ones, labels. So you can configure the font of it, the wrap behavior of it, buttons, you can control the selection behavior of it. And then there's 2 really kind of big classes, which we're just going to dive into. There's one called the table view. So table view is how you implement these scrollable views. And there's a collection view. And these are the most significant view classes that you'll ever work with. I spend most of my life in a table view, when I'm doing development. All right, so we're in the view area, and I guess good news is it's a very small set of views that you have to learn how to master, and you can use those small set of views to build any arbitrary app. Controllers. So controllers are supposed to be thin. In other words, controllers are supposed to have not a lot of code in them. If you have fat controllers or controllers with a lot of code in them, that's actually a smell that you've architected the app incorrectly. So a controller should only have these 4 tasks. So either I'm going to be handling an event that a view fired, and I'm going to be, when that happens, I'm going to be firing a network request, or I'm going to be navigating within the app, or I'm doing one of these other kind of 3 tasks, and that's it. Controllers are really meant to kind of tie things together. It's the integration layer of your application. So models. I think we listed almost everything inside the models, right? The only thing that there's a little extra piece here that you might find methods inside of your model classes that are data formatters. So in a tweet class, in a Twitter client, you're going to have like a tweet that says like 5 seconds ago. Is there a string in the model that says 5 seconds ago? Probably not, right? I mean, what is it going to be instead? Time. So timestamp could be a Unix timestamp, could be a date string, could be a native date time, right? Um, but it's certainly not. Certainly doesn't say 5 seconds ago. And so there's often going to be this case where you have this raw data that you're going to want to remassage in some way to present to your view template. And so I call those data formatters. Networking, very, very easy. It's probably like one of the easiest parts of iOS. So we're still in the good news territory. Models. Actually, there's one more comment I want to make about models. Why is models so easy? How come no one said business logic here? Most other classes will shout out business logic. Because you got it. Because like when we're making these clients, they're dummy clients, right? The API is the king. Whatever the API tells me to render in that page, oh, here's your Facebook stories for this page. Okay, paint. So you can either do just your typical RESTful actions, which is you either display your list of stories, you create a new story, you edit a story, you delete a story, but you don't make any decisions at the model layer. The model layer, if I were to look into your model classes and if I were to see any logic in there, I'd be like, what is going on? I hate smart entities that are everywhere because that generally speaking is going to be very hard to maintain. You have this smart server and a smart client, that'd be terrible. You want dumb clients so that you can focus all of your smarts on the server and all your testing around that. Networking, also very easy because there is like different types of networking. Like for example, like you mentioned, something that's similar, a technology similar to what we'd use to build chat clients, which is some kind of socket open, some kind of publish subscribe, maybe, right? Push notifications. But generally speaking, it's going to be a RESTful API client with authentication. So as long as we can do that. And what does that actually mean? Well, it's actually very, very simple. Your app, let's say that it's a mashup between Facebook and Flickr, or Facebook and Instagram. So you have the Facebook API and the Instagram API. So that means that you're going to have two classes, Facebook API client, Instagram API client. Guess how many methods are going to be in those classes? Well, one for every RESTful endpoint that you'll want to access. So for example, if you want to get a list of stories, you're going to have one method to get the list of stories. If you want to create a new story, you can have one method that creates a story. What's inside of those methods? Just the name of the URL that you're going to hit and whatever parameters that you want to pass into it. So clients, if you guys have built clients before, they're like clients in any other system, pretty straightforward, right? Except that you're going to have to authenticate, which means you're going to have to use some library to sign it so you can kind of get in the door.
Is there like a 30-second version of what a RESTful API is?
Yeah, so good question. So for those of you who aren't familiar with RESTful APIs, so I guess what happened was that people started building websites, right? They started building a lot of websites like Facebook and Twitter and Friendster and and they realized that these websites all fell into the same pattern. There was always this notion that you had basically what are called resources or nouns, right? Like for example, if I'm Amazon and I'm building a site, I'm going to have like products, right? So they realized that at any given web page, they're always doing the same thing. They're displaying a list of products, or for Facebook, a list of stories, or for Twitter, a list of tweets, right? So it's always like what's called like an index view of these kind of resources, right? Then they realized that they're always doing the same thing in the sense that once you had the list, sometimes you might want to see an individual list item that has more detail. So I'd click on a Facebook story and I'd go into a kind of what's called a show view of something that has more details to that particular item. Then they realized that, well, I might want to edit it or update it, right? And then they realized that I might want to create a new one. So I want to compose a new Facebook story. So this thing is called RESTful design because you can use these concepts of listing things, creating a new one, deleting one, and kind of jam every app idea into the schema design, which is like, what are your nouns? What are your objects? The users, tweets, shoes, products, stories, photos, right? Where each noun or RESTful resource has their relationships and their attributes, right? So I can have many shoes, but that shoe can be owned by also many other different people, right? So there's some way of describing their relationships. And so APIs are built kind of around this model of the world. So the kind of the final topic is hardware. And hardware in iOS is both easy and it's hard. So it's easy in the sense that all of the tasks that we're probably thinking of in the first, if I were to just kind of push you and let's think about things that we can do with the hardware, that will probably fall in the easy category because it's things that Apple has streamlined for us, right? It's trivial to get the location, right? It's trivial to kind of fire open the camera and get a photo, a UI image, an image from the camera. It's trivial to browse the photo library that the user has on their phone. If you want to access the sensor data, if you want to discover the Bluetooth devices that are out there, it's pretty straightforward, right? Just give me the list of, just like, a ping out there and see if there's any Bluetooth devices out there and give me that list. However, it's also very raw. And so what that means is that you can do a lot of cool things with it, but once you have a cool idea, it's probably going to be really hard. For example, people always get excited about the accelerometer and the various sensors that are on board. But the problem with those sensors, while very easy to get the data, here's your acceleration on any axis at any given point, right? How do you work with that acceleration data? How do you work with that sensor data? It's very challenging. So for example, Instagram made an app called Hyperlapse. That's super cool. Have you guys actually used Hyperlapse yet? Have you tried it out? So try it out. It's really neat because what it is, if you like movies, how do they get that really, really smooth filming, right? There's a couple of ways. They have really expensive rigs, and they have something called a Steadicam. So if a cameraman has literally $20,000 of equipment on him to make sure that he can kind of get this really smooth filming, and he has to have years of training kind of like to even walk correctly with all of this equipment. Right? It's actually, if I were to strap this $20,000 unit on you, you wouldn't necessarily be able to make this sweet, film, right? So what Instagram did was that they're like, well, I have this camera, and I have all of this knowledge of this orientation via this raw accelerometer data, right? So they can do what's called infer the camera pose, which is what is my 6 degree of freedom pose, XYZ, tilt, yaw, rotation, right? And then at any point, I can then cancel out the motion of my hand. So for example, there's going to be, as I'm panning here, there's going to be like a little high frequency noise. So that's me kind of shaking my camera a little bit because my hand's a little shaky. And then there's going to be low frequency, which is me slowly moving it across the room. So what Hyperlapse does is it replaces this $20,000 equipment and years of training and puts it in the hand of a novice user by canceling out my small hand motion and just showing my large hand motion, which will make it look like a very fluid picture. So that took probably several PhDs, and I think over 6 months, to even put together a prototype for that product. And so that's generally the feeling with working with hardware in iOS. It's very bimodal. It's either really easy or it's like really hard. There's very little things that are kind of in between. So a lot of good news so far, right? I mean, I'm kind of painting a picture where it seems like iOS is pretty straightforward, right? You have this hardware that's really easy to integrate with. You have networking that just has this very limited set of tasks, models that are dumb because the server is smart, controllers that just wire everything together. So what is hard about iOS then? What is challenging? Well, maybe similar to the web, it's this view layer is so difficult to get to make polished applications. So why is it so difficult? Well, it's difficult for a variety of reasons. iOS is built, not surprisingly, to make iOS apps. And so, man, there's very few apps that I couldn't whip together in like a day, right? Using the stock controls. But stock controls are boring, right? So let's say that I wanted to, if I wanted to kind of throw this up here, I'd put a UI page control and a scrollable view. We could be done in like, about 5 minutes, right? But what if my designer wants a cool effect where this like second dot will pulse a little bit for God knows what reason. Like let's say that as I scroll in, it has an effect where there's it just grows and shrinks a little bit. So the active one's a little bit bigger. The active dot's a little bit bigger. It makes sense, right? Active dot's a little bit bigger. And as I scroll, that one shrinks down, and then the next active dot becomes bigger. Kind of cool, right? So that takes that 5-minute exercise and probably changes it to a 2-day exercise. So all of the challenge in iOS is either making something completely custom that the framework doesn't natively support. And so once I have that behavior, I have to throw away the UI page control. I can no longer use it. Right? I have to build my own. And in the worst case scenario, you have to fight the framework, right? Because the framework wants you to behave a certain way. I have a different idea of how that might happen, and so you have to kind of fight against it. So that is another reason why it's so important. Like I have a lot of engineers who will kind of like throw together like the ugliest version of the Rotten Tomatoes client on the face of the planet, and they'll say, I got the gist of it. No. You're still in beginning iOS territory. If that's all you want to do, you should have just picked up a Big Nerd Ranch book and just like read it through. Because it's trivial. It's very easy to be able to like in a week kind of build the ugly version of this application. To build the polished version, that's where you build your intermediate and advanced iOS knowledge. Amy, who built this application, she was obsessed with this line going all the way to the end. It doesn't go all the way to the end by default. iOS 7 style is it kind of comes and has a little margin, right? She also wanted to pay really good, close attention to this poster image, such that like if you were to click on one of these posters, it's going to load the low res version first, and then it's going to seamlessly snap into the high res. So there is no progressive JPEG automatic loading in iOS. She did this manually, right? And so then you have to have a greater understanding of the threading model in iOS. So pursuing this polish will test your muscle as an iOS developer. And so like I'd like to see, if you're limited on time, what I expect to see pretty like vanilla applications. But if you really do want to challenge yourself, see if you can get parity with what she's implemented, right? Or what Casing is implemented here, right? I think his color choice is maybe a little bit questionable, but other than that, he has used both the table view as well as the collection view. He has kind of tuned a lot of the layout to kind of make it look good. And like Amy, he also knocked down all of these optional tasks, which is kind of your goal. Your goal is like Pokemon, kind of collect them all. So in the next 50 minutes, I'm going to actually start to like try to connect these high-level concepts. For if you still don't understand, if you haven't done MVC before, you didn't quite follow that, that's okay. We're just going to start building real apps, and then I'll kind of see if we can reconnect it back to these actual patterns. So let's take a break. Let's take a quick break, 5 minutes, and then I'll restart at 11:03 with actually building the Rotten Tomatoes client. So what I'd like to do is I'd like to work with this API. So Rotten Tomatoes here. So this is what a RESTful API looks like. So the key parts of this, so there's a lot of garbage here for people who haven't seen RESTful APIs before, but let me highlight the key parts. So this part is what the nouns that they've chosen, right? So they've decided that there's lists within Rotten Tomatoes, and they've decided that within those lists you're going to have one of those types is going to be a movie, and they've decided that one of the movies is going to be box office as opposed to DVD, right? And then so that's kind of like how you get the collection of items from the API, and the rest of it is just parameters to tell you like how many do you want pagination and so forth. And so once you get that, once you hit this unauthenticated API, you get this JSON response, and this looks like the JSON response of every other API that's out there. And so what it looks like is it's a dictionary that has kind of keys and values. And for example, the key here for movies will contain the array of 28 movies in the box office right now. I can expand this, and then this will be a dictionary. So each dictionary will contain one movie. And so each key in here is an attribute of a particular movie. Right? So this is the API that we'd like to work with if we could. So I'm going to go ahead and create a new Xcode project. Right? I'm going to create a single view application. At no point will you ever use one of these other templates, no matter if you're a beginning or advanced iOS developer. So I like simple decision trees. Here, this decision tree is always one decision, the single view application. And then I'm going to create this Rotten Tomatoes client. Now I'm going to select, so choose your organization identifier. It's always going to be com.something. So it can be com.facebook, it can be com.your, not a personal startup name, it can be com.your name. And then you choose your language. So for us, we're going to learn Objective-C. But now is a good time for us to discuss Objective-C versus Swift. As you may have known, am I learning something backwards because I'm learning Objective-C? Well, not quite. So let me give you the kind of full color, because there's a lot of like hubbub about Swift. There's a lot of conversations on Hacker News about it, and it's not what the masses necessarily are saying. So let me kind of give you the full color behind this. So you would think that Swift is just it's the best because it's the latest, right? It's the latest and greatest. But would it surprise you to learn that among the tens of thousands of engineers at Apple, only 200 of them were aware of the existence of Swift when it was announced at WWDC? Oh, wait, are you telling me they haven't been dogfooding and testing this language for years and just now giving us access to it? No, it's hot off the press. Like weeks before they were announcing at WWDC, they were still changing really core ways that the language even works, right? So is it the best? No, it's the newest, right? And there's things about it that are cool. But what's interesting is, anyone know Ruby or Python maybe? Okay, so I love dynamic languages. That's my preference. I grew up in C and C++ and very strict languages, and I'm like, oh, what do you mean types can be anything? Like, that's insane. Chaos will ensue, right? But then after like working with it, I'm like, actually, it's kind of growing on me, right? So what's interesting is Objective-C looks gnarly. It has the appearance of one of those really crufty old languages because it's a strict superset of C. What most people don't realize is that Objective-C and Ruby share the same ancestor, Smalltalk. And so once you get past their exterior, under the hood, you work with them almost identically, right? So any patterns that you might like in Ruby, Objective-C probably has the same pattern. Swift looks gorgeous, right? They cut off all of the C stuff. It looks like a very modern language. But as compared to Objective-C, they probably made the opposite decision in every single way. The name of the game for Swift is safety. So for example, everything is extremely type strict. You want to multiply a float and a double together? No, that's an error. What language doesn't allow you to multiply a float and a double together? Like CG float versus float, they're going to make a big fuss about the difference between these two things. So everything has to be explicitly cast, right? They hate implicit casting in Swift. Did you miss generics from back in the day from C++? They're back, you know. So if you want to make generic classes, you have to learn this funky like generic syntax. So Swift, is it better? I don't know. It's different. I think what happened was a bunch of language nerds went up to a nerd ivory tower of ideal language, and said, what if y had a variable? And what if a variable could or could not exist? And let me call these optionals. And let me give you like 3 different ways to unwrap these optional. And basically it was so, in my opinion, useless, but everyone has their language preference. There's probably people among this room who are like, you're an idiot, you don't know what you're talking about. Type safety is really, really important. So it's just one of those things where programmers have a spectrum of opinion, right? But for better or for worse, they're both here, and they're both going to be here for a long time. At no point will Swift crush Objective-C out of existence, and there's no unringing the Swift bell too. So they're both here for good. And the reality of the situation is that if you want to do iOS development in the future, you need to know both. But the good news is, you guys probably know at least 3, 4, 5 languages already, right? Anyone? Pascal, Basic, C++, C, C#. You guys probably already have a huge history of languages. Learning 2 more, it's all the same, right? Variables, conditionals, loops, instantiation. There's only a couple aspects of the language that are always kind of different, right? So for Objective-C, it's the fact that you have open classes, just like you have in Ruby. Swift and Objective-C both have open classes, which means that you can willy-nilly add new methods to classes that you didn't create yourself, which is a pretty cool feature. So Swift has extensions, Objective-C has categories, and they're identical. Swift and Objective-C are not a managed language. So this is something that always kind of catches people by surprise. It's not a managed language like in the way that Java, Ruby, and Python are. You still need to understand memory management. But luckily, there's this compile time system called Arc that hides away a lot of this, so you can almost treat it like Ruby or Java, except that you have to be aware of something called strong versus weak, which you should look into. So the name of the game is like you guys are probably on your own for learning the language. You should be. I'm not going to teach it in the class. I'm going to expect you to kind of ramp up very quickly on it yourself, like you would in any other language. Languages take a couple days to learn. The majority of this class is about learning the framework, right? And by the way, if you do want to learn Swift, if you do like these kind of language features and you prefer them over Objective-C, it's basically the same framework method that we're going to be learning in class called using the Swift syntax. So the usage of the framework itself has not changed. So I'm going to continue this in Objective-C.
What was core data?
Core data is something that we're going to learn about. It's the persistence system. It's how you save data in iOS. So we're not going to do that for right off. Facebook, I believe, forbids the use of core data within Facebook. Just FYI. A lot of people actually, it's like half and half on people who actually use core data.
So the same as DNS default that we did for the tip thing?
No. So there's 4 types of persistence, which we'll cover when we get to persistence. Core data is one of them. The cookie store that you guys were using, Annis user defaults, is another one. So I'm going to take these 3 files, view controller and main storyboard, I'm going to delete them. So these are kind of useless files because the view controller is, that's like a non-semantic name, right? A view controller is a screen in the application, and so we're just going to delete this. Now I'm going to go to the app delegate. So the app delegate is a file that chooses what the initial screen is, right? So it manages what's called the application lifecycle. So the main point of it is it's kind of like void main. It's where your application begins life, and its primary job is to choose the initial screen. There's also other aspects of its responsibility, which it also understands when the app goes to sleep and wakes back up or receives a push notification. So those are in a full app, those are the full range of tasks that are in here. But for the most part, this is the key method that did finish launching with options, and now, here we are in void main. Where do you want to go from here? So I'm going to create a screen. So the interesting thing about iOS is kind of like designing a website, every screen is developed independently. When you're making a web page, like imagine you're making the Facebook homepage, Facebook website, right? So if I'm developing the profile page, I'm not thinking about the home page or the story page. Like every page is developed independently. Now they do have a shared model, but they have very limited relationships with each other. And so for us, a view controller is a synonym for a screen, right? So one screen is equal to one view controller. And so for example, if I want that list of movies, that feed of movies for Rotten Tomatoes, I'm going to create a movies view controller. And I'm also going to create this thing called a zip file. So we're going to learn a couple ways of how to create views in iOS. And so one of them is creating, using something called Interface Builder. So once I create this screen, kind of put it up here, and I'm going to do something where I disable auto layout. Auto layout is that mechanism that I was telling you about where you can have your screens respond elastically to iPhone 5, 6, 6 Plus. And I'm going to turn this off for now. This will be the last week that we turn auto layout off. Starting next week, we'll be using auto layout. And so you can see that my kind of Apple Watch shaped thing goes away and my iPhone shaped thing comes back. So I just clicked on this document on the upper right-hand side, this thing right here, and then I unchecked this use auto layout thing right here. So if I click on properties here, which is this little slider thing, and then I hit the background, I'm just going to change it to, say, this green. And then in the app delegate, I'm going to import the movies view controller, and I'm going to say, hey, app delegate, can you load up the movies view controller? So I do have to create this thing called a key window. So windows is not a very important concept in iOS. You can go months, years without even thinking about the fact that this window exists. This window contains your entire application. It's like kind of the body in HTML. And then inside of this body, I'm going to say, hey, what do you want your first content div to be? So for me, I want it to be this movies view controller, so I'm going to instantiate it. So movies view controller with crazy bracket syntax. Self.window.root view controller is equal to VC. So what I've done now is I've said, hey, here's your first screen. So I've got my puke green screen right here. So I've proven that I can design a screen and then set it to be the initial screen. So with Tip Calculator, maybe you observe that, well, to design a given view, it's pretty straightforward. I just start to drag elements onto this screen, or you can programmatically create them, right? Drag elements onto the screen and lay them out wherever you want, right? So what I want to explore today is what I said was that more challenging view class, which is the table view. So I'm going to come in here, and I'm going to look at all of my options for controls. Remember that you rarely will use most of these. You're only going to be using labels and images for most of your iOS career. And then grab a table view. You at no point use the table view controller. This is off limits here. So don't use that. Because the table view controller tries to do things for you, which is helpful, but then it has limitations in real life. So once you start building real apps, you're like, oh gosh, table view controller really wants the root view to be a table view and it insists on it. And well, that doesn't work for a lot of applications. And so, but luckily, it only gives you a few things for free. So we're going to, in fact, replicate the behavior of table view just right now in the next few moments. So I'm going to drag this table view object onto this screen. And where? So it's this on the right-hand panel. So you have the paneling on the upper right-hand corner that can show and hide the left, bottom, and right. You show the right-hand one, and then you make sure that this circle with the square inside of it is selected. Do you see this icon? Are you on a view controller? You've selected a view controller? So it's this thing here. Maybe someone else can show you. So while someone's showing you that, I'm just going to run this and show you what it looks like. So Xcode's a little bit buggy these days. I'm going to have to restart Xcode. Xcode's been very, very stable up until this latest version, Xcode 6, which has been a little bit frustrating. Did you figure it out?
It's a different version of Xcode.
Well, this has been the same for a long time, but
No, I'm not. It's on that. Or which version?
so by the way, you should be on the very latest version of Xcode. You're going to run into problems if you're using an old version. There's been a lot of changes in Xcode, and so you want to be on the latest. What's that? You can be the latest on Mavericks. That's fine, or upgrade to Yosemite if you can. So here I am on showing the table view. So I have the table view here. I don't know if you can see it in the distance, but there's actually lines that can kind of scroll here, right? So what I like to do now is I like to fill this table with data. So whenever I want to whenever I want to attach to something that I described here, I create an outlet, right? This is like creating an ID. This is like creating an ID in HTML so that I can access it via CSS or JavaScript, right? So on my view side on the left, I want to be able to interact with it, so I create an outlet, right? So this is a table view. So let me kind of make this full screen so we get a little bit more room. Okay, cool. So how do I start to jam things into this table view? Well, I say self.tableview dot data source is equal to self. So what I'm saying is table view as an entity, I'm going to tell you what those rows should contain. So you just trust me, I'll handle it. And of course it's complaining right now because the table view is like, are you sure? Because in order to be a data source, you really have to implement this protocol, the UI table view data source. And so I'll say, okay, yes, I am sure. Table view data source. So what does it take to be a data source? Well, it's actually just two responsibilities. So I have to tell it how many rows do you want in your table? So if I say it's going to call this method on me. So the table view, because it's going to call a method on the data source, which is say, hey, return me the number of rows. So I'll tell it. I'll say return 100. Right? And then it's going to say, hey, well, what do you want each row to contain? What view hierarchy do you want it to contain? So that's called the UI table view cell. So what is a cell? Well, it's just a view. So a view is just an arbitrary rectangle, right? And so why a cell? Well, a cell has things, it's basically just like an empty rectangle, because it has a few bonus features inside of it. You know how you can do swipe to delete in iOS? You get that red thing? That's built into the cell. Right? You know how you can get the reorder controls, which are those 3 lines to be able to drag cells around? That's within the cell. Cells also support an intrinsic a state of selected versus highlighted versus default. They also support a few things like an accessory view, which is that arrow key on the far right-hand side. So it's basically a view. You can think of it as a view with a few special features that are common in table views. And so I'm going to do something which you'll never do in real life, which is I'm just going to create a cell in this way, which is just a UI table view cell, alloc init. This is not how you'll do this later. So I'm going to say, give me just a default cell, and a default cell comes with a built-in label, which I'm just going to say something here. All right, so just like that, I have my table view with some ghetto stuff inside of it. But that's not very fun for various reasons. But let's explore what we have now, and let's see if we can kind of build up on this a little bit. So I'm going to kind of print out here nslog, and I notice I have a parameter here. It's an ns index path. If I command click on ns index path, it's going to take me to the header file of ns index path, so I can see kind of stuff that it contains. So what it actually consists of is a row and a section. So let me kind of prove that. So I'll have section. So how many times do you think we'll see this log statement when I hit run again? 100 times?
100.
100? Why not 100? Ah.
Oh, you have to scroll down.
So
I can scroll back up.
if you look at this, you can see that I can scroll all the way down to oh, I see what happened. It's up here. So the behavior of that wasn't very clear. So as I'm scrolling up, like let's say that right now only these are visible. If I scroll back up, let me actually make kind of a change so we can see which row is which. So here I'm going to take this thing right here and say display it right here. So I'm going to do string with format, which is string.format if you're more familiar with Java. This. So let's put the things in here and take a look. So as we can see, the 12th row is here. And if I scroll down, it triggers the 13th row to be called and re-rendered, right? So now off the screen is row row 0 is now off the screen, right? So the question is, if I scroll back, am I going to see row 0 called, or is it going to be pre-warmed because it's already been hit?
See the call.
So one guess that we'll see the call. All right. So what's the takeaway here? Table views are extremely aggressive about kicking things out of memory once your thing is rolled off the screen. That's kind of their job, right? And in fact, we've done something which is not good, in the sense that, like, think about how many times this method is being called, and we have an alloc and init. Have you guys ever done performance optimization before in your life? So performance optimization, like, it's kind of funny. The naive person goes to the CPU monitoring first, but that's not the right first stop. It's the memory usage, right? So memory allocation is by far the most expensive thing, whether you're doing backend or you're doing mobile. So you want to try to minimize your memory allocation. And so in this method, at no point should you ever have an alloc init, because you don't want to have construction happening when you're scrolling. Because scrolling, what's the sign of a bad app? Jittery scrolling, right? And so you definitely want to have minimize this allocation. So there's a built-in process to do this inside of a table view called dequeuing. So what that does is it maintains a bag of unused cells. And so if I say, hey, give me a cell, I'm like, oh, I'm not going to create a new one for you. Let me kind of rummage around in here for this old cell. Here is a cell. And then you can set properties on it to reconfigure its look and make it yours. And then you're good to go. So you're able to reuse this memory and never have any allocation within this method. So
Also, this one, like, we are explicitly allocating somewhere, but who deallocates them?
So that's the kind of the beauty of what's called ARC, automatic reference counting. You can almost treat it like a garbage collected system, where if you're doing alloc and inits, just don't worry about it. It's going to be cleaned up. In fact, in this case, it'll be cleaned up once it leaves scope, unless something else is using it. This works based on a very naive reference counting system, so if you're familiar with that. If you're not familiar with reference counting memory systems, the takeaway is just like, don't worry about it. Just if it's alloc and init, it'll be taken care of. It's just like Ruby or Python where you might not care about it. So the next thing that I want to do is I want to actually pull data from that JSON feed, right? So I have this cool URL here, which I know gives me this structured data, right? So wouldn't it be neat if I could display that as a list of titles in here? So I start off in this view.did_load. So view.did_load is kind of like document ready. It's kind of exactly like what it sounds like. There is a life cycle to these screens, as view controllers, and the view.did_load means like, I've woken up. What did you want? Okay, cool. I've set up your view hierarchy for you and registered all your event handlers. And okay, good. Here, I'm going to turn this over to you. Anything you want to do before we go to sleep and wait for an event to happen. So view.did_load is that moment. And so for me, I'll say, okay, well, let me just kind of fire off this URL. So this URL, the first aspect of it is you just capture the URL of this class NSURL. So NSURL is a very dumb class. All it does is it's responsible for making the canonical representation of a URL, right? So it takes some path and it just captures it. The NSL URL request contains the URL. The request is also a pretty dumb class. All the URL request does is it takes that URL and allows you to specify, well, do you prefer any caching policy to this? Would you like to, me to kind of save this to disk and return it for you if you have it available? Do you want me to include any parameters in this URL request? So again, the request is more specifications, right? So it's also a dumb class. It's just responsible for capturing some of your preferences.
Is this where you would put like post parameters and things like that?
That's where you put your post parameters and things like that. And so next is the only smart class, which is the URL connection. This is what reads your requirements here and actually does work, right? So I'm going to take my request and I'm going to automatically background it and I'm going to fire off the request. When that request comes back to you, well, which thread would you like me to run it in? The answer is almost always just the main thread. So I'm going to tell it, hey, when you come back, run my handler, my completion handler, in the main thread. And so I'm going to hit tab to go to this next thing. This is a block, right? An Objective-C block. Objective-C blocks, I'm convinced that I don't know how long it took me to memorize the syntax of an Objective-C block. I still copy paste it a lot to this day, because not only is it gnarly, but it's different in different situations that you have it in. So oftentimes you'll be able to hit enter and autocomplete them. There's a site which I will secretly go to whenever I close my office door. I'll be like, no, there's no way I would forget all this. It's called Gosh Darn Block Syntax. So the reason why it's so gnarly is because it's different depending on the situation that you're in. These are the 4 major situations. You can have a local variable that stores this chunk of code, right? And in this case, you have your parentheses and your carets just so. You can have a property which is very similar, but then you can pass it in and look how it's changed, right? So it's not parentheses, caret, it's some other garbage, right? So this is something that I'll kind of pull up, and then I'll kind of reopen my Office door after. I'm like, oh, of course, I would never have forgotten that. So here I am in this NS URL with string. I was actually passing in a string here. Actually need to construct an NS URL. Okay, so at this point, this code right here, I'm actually running on a different. This actually came in and was run kind of asynchronously, right? So this code actually has the NS data, which is the raw binary data. So that's not very useful for me. For me, I'd prefer it to be, wouldn't it be great if it was just in a dictionary? And so if I use this thing called an NS JSON serialization, I can take that binary data and parse it, right? So if I want to say grab my JSON object with this particular piece of data and just accept the kind of the default options here, you'll never, I don't think I've ever specified anything other than 0 and null for JSON deserialization. And let's print that out. See what we got.
So that you print an object?
Yeah, the %@ is the notation for an object. And so just like I had in Chrome, I have this structured data. And what's cool is, even though this looks like a gigantic blob of garbage, it's actually been split into NS dictionaries, NS arrays, strings. So it's actually ready to go. All I need to do after this is to put it into my model classes so I can access it. So at this point, I'm going to grab that movies array. How might I? Does anyone remember the syntax for accessing a dictionary? Has anyone looked that up yet? So if you're dealing with a hash map or a dictionary, you obviously want to access it by its key, right? So I'm going to create a new property, @property, non-atomic strong. Should this be non-atomic or atomic? It should always be non-atomic. Strong or weak, it should always be strong, unless it's a delegate, in which case it should be weak. There's we can talk for an hour about memory management in Objective-C or Swift. It's the same thing. And it'll essentially just boil down to those heuristics on a day-to-day basis.
What you said sounds like basically gibberish to me. Is that normal?
Oh. No, it's probably me messing up. Okay, so what I was trying to do is I was trying to say there's more complexities here, right? And so we can talk about those complexities, but it's going to boil down to you implementing a certain set of simple rules, which are whenever you're describing a property here, you should always, it's expecting these attributes here. And so always basically write this. In fact, if in this class, everything always has these 2 words in it, you'll be fine. You may occasionally leak memory, but that's fine. If you want to be a little bit more advanced, you can remember that if it's a delegate here, this should be weak. So here I am, I'm grabbing the movies. And I want to kind of grab the key out of this, right? So I have that response dictionary, And the way that I specify keys, I put the key right here, right? So what should the key be in this case? Or how would I know?
You look at the JSON.
I look at the JSON.
Movie style.
So it would just be movies, right, to get this array. And now I have this inside of my property here. So I want to do a gut check for the rest for everybody here. Like, how are we doing? Is this any confusing points that you want me to elaborate on? Is this like, yeah, go ahead.
Is that block syntax like a
Yeah. So this gnarly like bunch of like code, which eventually will look normal. So this part of it, this completion handler is the parameter, and this junk right here is like the callback, right? So if we were, do you know JavaScript by chance? All right, so this is the area where you would be putting your, callback function.
What the caret symbol there is just a way to say parameters.
No, it's how you specify a block. It's how you it's a syntax for an anonymous block. Right.
What's a block then?
Um,
Unnamed function.
it's an unnamed function.
Sometimes closure.
It's a closure. It is a closure. So that's exactly correct. It's for those of you who know what a closure is. It's a closure. Does that make sense?
Yeah.
Okay. By the way, like I'm sorry if this wasn't clear, but like you actually have to learn Objective C. Kind of like I was kind of expecting you to learn it like before the class a little bit. So if you haven't done it that yet, maybe like hit up a reference manual this week and just kind of cover. It should be pretty straightforward. There's only a few topics that are interesting: blocks, properties, right? If you know blocks and you know properties, you know how to like pass parameters in like this crazy, the rectangle syntax. You have the language under control for in large part. Okay. So, but do let me know if you have any language questions. But I'm going to assume that you all are going to successfully read the reference manual for it yourselves. So here I am in self.movies, and then I want to return here now, not 100, but what?
The size of the movie array.
Yep, the size of the movie array. And then inside of here, so instead of the text here, I'm going to grab an NS dictionary. IndexPath.row. So this is the nth dictionary. And the movie itself is a key. And if I wanted to display the text here, what do I do?
Self movies title.
So
Oh,
movie
title.
exactly. So I'll access it like any other kind of hash map. Now I'm going to kind of put a print statement here that says movie count. Shit. And then I'm going to put a print statement here. So I say got the response. And then I'm just going to put a print statement here that says finished setting up view did load. All right, so let's see if we can see a list of titles here. Uh-oh. It's blank.
Movie count 0.
Movie count 0. And if you look at the order here, you see got the response. It looks like it comes first, but in fact it comes after the finished setting up.
Because it's async.
Because it's async. This is not the actual code that's going to be run now. This is a closure. This is a block. This is an anonymous thing that's going to be run later whenever the network request comes back. And so the table view is not willy-nilly asking me all the time, hey, what is the movie count, right? It's only going to ask me once, right? Until I say, all right, well, I know your underlying data source has changed, So go ahead and reload your data. So re-ask me those questions. And then I can see here that I got the response. Subtable view.
Could you go back down because the block you finished first?
What's that?
Can we see the table view code again?
Yes. Hang on one second.
That makes sense, right? It says the view, and then it gets a response, and then it updates the table.
So here we have the list of movie titles. So we've successfully kind of done a very basic version of what's called the template rendering. So for those of you who've never done GUI, this is what's called template rendering. I got data back. I have this really naive template, which is just a single label, and I filled in what the label should be. That's what they mean when they say template rendering. But this is obviously ugly, right? I mean, this is the little single line of text. I want it to look like a Rotten Tomatoes thing. So what I'm going to do here is I'm going to start to organize this a little bit. I'm going to create a new group for my views. I'm going to create a new group for my view controllers. I'm going to start to drag these into there. And then I'm going to create a new custom view. So instead of a UI view controller, I'm going to create a UI table view cell. And it's going to be a movie cell. So I'm also going to create a zip file. So if you look at this, this is how you create a custom cell, right? Remember how I told you you never actually use UI table view cells stock? So I'm going to throw this into my views, my custom views area, and I'm going to start to design it, just like I designed that tip calculator. So when I did that, I said, okay, well, I guess I want a label here. And maybe I want a label here for the synopsis. So here's the title. And then maybe throw the image view in there for the poster. Right, so I got the beginnings of something. And so I could continue and refine this, right? Now, in the view controller, what did I do in order to kind of configure these or give myself access to these programmatically? Create the outlet. So I go to these double rings right here, or the tuxedo, depending on which version of Xcode you're on. And I will drag inside of here. So this bug happens sometimes where it doesn't match up the file with the thing. It's because this has switched back into manual mode. If you kind of come up here, every time it doesn't match up, just double check to see it should be an automatic. And then I'm going to use a shortcut key, Control Command Up arrow. It's a very convenient one. It toggles between the header file and the implementation file. So I'm going to say drag this label into here and call it, say, title label. Drag this label in here and call it synopsis label. And drag this image into here. And you would think maybe you'd call it image view, right? But call it poster view instead. So image view is actually used by the UI table view cell, so it'll collide if you call it an image view. So if you forget that, what you'll see is the image will flicker a little bit weirdly. So it won't crash. It'll just like flicker. So that's what's causing that kind of weird behavior. So I have something here that I would be happy with if I could only get it into that table view cell. So there's a bit of an incantation here where I have to say, inside of this table view class, I have to import the movie cell, right? And then here in the table view, I have to say, remember how the table view is going to contain that bag of unused cells? Well, there's a mechanism to make that work. I have to tell the table view, hey, table view, I want to register something here. So I'm going to register a nib. A nib is this, see this XIB thing? That's a nib. Nib, zib, these are synonyms. The nib is just a compiled version of this XML format. So I'm going to say, table view, here's this nib file, this zib file, called movie cell in the default bundle, which is just the default resources. And whenever I give you this identifier, movie cell, right? This movie cell right here. So whenever I say this string, you go and you find this nib and instantiate a version of it, right? So you give me a copy. I want a copy of this basically, right? So I'm registering this object with this string. And then in here, instead of this UI table view cell is equal to alloc init, because remember we don't want to do alloc inits. Instead, I want a movie cell where that is equal to table view, and there's a DQ reusable cell with identifier movie cell. So what this says is, this is like, I know it's a kind of a weird word, but it's like, just give me a use cell. So instead of DQ, you can say just give me reuse cell, give me a reusable cell, which says if it doesn't have one, it'll do the alloc init for you of the movie cell class.
Does it pre-allocate?
No. So everything's lazy. In mobile, almost everything's lazy. You very rarely do pre-warming. So here in table view, you grab this cell, and then I can, at this point, now set the title label to title, and then the cell dot synopsis label dot text is equal to movie synopsis. So what we saw here was that all the cells were overlapping with each other. And so let me fix a couple things here. For this week, we're just going to use static height table rows. So row height is equal to 100. Next week, we'll do dynamic height table. Believe it or not, it's kind of obnoxious how you actually get dynamic height rows. You'd think it'd be easier, but it's not. And then in this movie cell, let me just make this synopsis. There's a key property and a label on this far right. You see this number of lines. If I do 2, you can have up to 2 rows, 3 rows before it truncates. If I do 0, it says keep on wrapping until you're finished with your content. So if I run this, then I actually have the beginnings of my Rotten Tomatoes table view. Now this still looks ugly, right? But actually we've done something really key. I don't know if you, let me give you a moment to let this sink in for a minute. In the tip calculator, if our life was just building screens that just had static elements on it, it's pretty straightforward, right? I have the screen, I just drag in labels, images, buttons, those category of views and put them in there. But that's not how real apps are. Real apps are scrollable, right? So now we had this admittedly kind of weird incantation, this set of steps, cell registration, cell for row, whatever. But if you follow those steps, and you get this awesome thing where you can actually treat each of these kind of like we were treating an individual view controller before, right? And so, for example, if I come back to this mobile pattern site, I wasn't kidding when I told you that I spend most of my life in a table view, right? Let's take a look at this, because these all look very, very different, right? So check this out. This is just a table view with a cell that has a label and 3 images, and this little button here that's a little arrow. If I continue to scroll down here, what's interesting is that so this is a table view right here. Even this is a table view. See how this is a cell, this is a cell, this is a cell. Even something like this is a table view. This is the cell, 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 and then even the OK then is in a little cell or header. This is a table view here. This is a table view here. This is a table view. This is a table view. And so I would say that probably 90% of screens in iOS is within the context of a table view. So that's why we're trying to tackle it in this first week, right? This is probably a collection view. So collection view is the same as a table view, except it can support grids, not just simple rows. So wouldn't it be great if I could load up this image, right? So let's try to do that. So here in my JSON payload, I have this posters thumbnail. You see, so it's kind of a nested structure. So I can't just directly access the key. Well, there's this shortcut syntax that you can use that says, ns string URL is equal to movie and then value for key path. Posters.thumbnail. So the reason that we're using this value for key path instead of this thing is anytime we want to kind of nest into a nested dictionary structure, you can use this dot notation, which is a little bit easier to do. You could also just unwrap them manually, pull the posters, store it into a dictionary, then access the thumbnail key that way. And then so I want to take that cell.poster view and I want to set this URL to it. Uh-oh. Apparently it's expecting the bitmap image to be there immediately, right? So a UI image view has no facility to actually download this image for me. So what I want to do is I'd like to introduce how you do dependency management in iOS. So if I go to my desktop where my Rotten Tomatoes app is, and here's my project, right? So it just has these 3 files. I'm going to add a file called a pod file. So what a pod file is it's a text file where you just list all of the libraries that you want. So there's thousands of libraries that you can potentially access, right? And so you just list pod, whatever, pod, third-party alert view, pod, anything else that you might want, right? So after you list it here, you call pod install. So pod install will go to the network. It will fetch the library. It will manage all of your dependencies. For example, if you're using libraries A, B, and C, but A also uses C and B also uses C, then it'll fetch C only once. In fact, you can even specify, like, sometimes libraries have version dependencies as well. And so this system will negotiate all of that. Pay attention to this key line right now, which is from now on use RottenTomatoes.exe workspace, which is different from xcproj. So let me open up the Xcode workspace, and maybe you can kind of see why it's different. So if I open up the workspace, and if I look to my upper left, an Xcode workspace is pretty straightforward. It's simply a container from multiple projects. And so CocoaPods leverages this to create this other project called Pods, which has, if you can see, all of my dependent libraries. So if I expand to Rotten Tomatoes, and I want to now leverage one of my favorite features, which is an Objective-C category. A category is a way to add a method to kind of an existing class. So if I say, I wish my UI image view was better. I wish it was also included the AF networking extensions. So now if I go back to this and I do set image, remember how I only had set image before? Now magically I have this extra functionality, which is kind of cool. And so I'd say, hey, well, I actually do have the URL. Right? And so if I were to try to run this, then I should see kind of my, fingers crossed, my posters views appearing here. So the moral of that story was really I wanted just to use this as an excuse to tell you about the CocoaPod system and this notion of like kind of pulling in libraries that you're going to use for your projects. And I encourage you to do that, all throughout the class, right? Just shop around, start to learn how to integrate, other people's libraries. So the final thing I want to mention for today is I'd like to be able to click on this cell and then go into a details page. And so if I, in order to do that, I need to capture the click. Well, every kind of class has events that happen with it. So self.tableView.delegate is equal to self. What this is that this is saying, hey, I want to be the listener for all of your events. It's a little bit different from JavaScript in the sense that, there's not just there's only one listener in general that gets all of the events, not like a different kind of block for all these different events. So I'm the delegate, so you give me all of your events that you might get. And so those events are listed in the UI table view delegate. So the UI scroll view delegate has one, UI text view delegate. So every class typically will have a set of events. So the event of interest here is the did select row at index path. So I want to know when someone tapped on a cell. So if I look at this, you can tell that you see how the selection stays selected. That's the default behavior, right? But in most apps, what happens in a selection is that the table will acknowledge that you've selected it, and it'll fade away this selection. So if I go table view, deselect row at index path, animated, then here I've proven to you that I've successfully captured the event, right? And so now what I'd like to do is I'd like to create a second class called the movie, so UI view controller, the movie detail view controller, which is maybe what that looks like, right? And I'll also create the zip file. So I'll come in here, I'll delete this, disable auto layout. You know, if you want to make something like what Amy did, then you would have the image view in the back, right? And then she has a scrollable view, so a UI scroll view. A table view is just a subclass of a UI scroll view. So a UI scroll view doesn't have any of the dequeuing. It's just a naive thing that can, you know, scroll content. And then I'll put in a couple labels, right? So if I look at the view hierarchy here, I can see that the image view and the scroll view are peers, right? And then the labels are contained within the scroll view. In other words, the image view is going to stick in the back while the labels will scroll. Finally, what you want to do is you need to create another class called a UI navigation controller. So remember how I told you that every view controller controls the entire screen? I lied a little bit in the sense that like you do obviously have multiple view controllers somehow accessible. You have three types of navigation in iOS. You have tabs at the bottom, 1, 2, 3. Each tab will bring in a new screen, right? And then you have the type of navigation that you're very familiar with as a user, which is if you tap on things, a new thing will slide in, right? So it's a lot like kind of a Safari browser or Chrome browser experience. You know, you can navigate and it builds up this history stack. The third one is called a modal, which is like the light box on the web, right? So like it's when another screen comes kind of into place. So as soon as I wrap this navigation controller around this root view controller, then I can see that I get this like navigation bar at the top here. And not only that, but I get everything else that comes with Chrome, which is now I have the chroming, but I also have this history of navigation. So if I go into this movie view controller in the selection, let me import my new class, import movie detail view controller. And then in the selection, allocate that movie detail view controller. And then do something called access my navigation controller and push this new view controller on it. This is the same as, like, let's say that I had done link navigation. So you know how you're on a web page and you want to support a link, you do a redirect, right? So this is me kind of saying, well, go to the next page. And then this will kind of handle the animation of that as well as that back history. So you get that for free with the navigation controller, and that's its purpose. Now, notice how this is blank. So just, I know I'm running out of time. So if you just had a property called movie on the VC, and then you notice how I'm also getting the index path back here. So imagine if you did something like this, you could set a property on the next view controller that tells it what movie it should be rendering. And so that's kind of like how to stitch together these two screens. So that's it for today. If you haven't submitted your tip calculator, you need to submit it by today. In general, you know, and like I said, to participate in the class, we have to keep you on a certain pacing, otherwise you'll fall behind. So read up on Objective-C, finish the tip calculator, and then get started in this Rotten Tomatoes application just by watching the video and following what I've done so far. On Thursday, we're going to practice this again, hands-on, not me talking, but you guys just working on the Instagram client. So I'll help you through that process.
Cool, so you want us to do Rotten Tomatoes?